Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Well fellas, now we're gonna solve the third part of previous problem. So if you have missed the previous episode, don't worry. I'll put the link to the previous episode at the end of this video tutorial. Okay. So I will put the full playlist at the end of this video tutorial. So stay chill. Okay. So previously we have discussed about finding the order of H plus ion of this particular reaction and finding the order of Br minus of this particular reaction. Then we have extract the rate equation for this particular reaction from using this data. Okay. So now let us at first read the question. Use the data from experiment 1, from this particular experiment 1, and use your answer your answer. Use the data from experiment 1 and your answer to A2 to calculate the value of the rate constant. So they want us to find the rate constant of this particular reaction. Okay, so include units to your answer. Include units in your answer. So as you can see that the total mark for this question is 3. Okay, so for calculation we will gain 2 marks. So for calculation we will gain 2 marks, and for the unit we will gain 1 mark. So in total we will gain 3 marks. So that's the mark distribution of this question. Okay, so the first 2 marks are for calculating the rate constant, and the last 1 mark is for the unit. Okay, so that's how it goes. So before answering this question, let us write the rate equation for this particular reaction. Okay, so rate, let us involve the, okay, let us write the unit. Not here. Later on we're gonna involve unit of rate. Okay, rate and all these things. Okay, so at first let us write the rate equation. So this is BrO3 minus then H plus square whole square Br minus. Okay. So let me put it in another way. Okay. So this is the rate equation for this particular reaction. So this is the rate equation for this particular reaction. Okay. So now let us look at the information that is given. So they have asked us to use the information that is given on experiment 1. So if we use other experiments data, then the whole answer would be invalid. Okay, so we should be careful about this thing. Okay, so most of the student might get into the trap of this small thing. So this is a trap, so we need to be careful about this thing. So they have asked us to use the data of experiment 1. Okay, so let's do it. So we're gonna use the data of experiment 1. So in here we can see that the initial rate is 1.68 1.68 into 10 to the power minus 5. So in here it is 1.68 into 10 to the power minus 5. Let us include the unit for in order to find the units of the constant k, rate constant k. Okay. Let me write this once again. It's getting annoying. So let us write the rate equation once again. Rate is equals to k uh, BRO3 minus h plus square PR minus. Okay. Is this the rate equation? Yeah, hopefully yes. So yeah, this is the rate equation for this particular relation. So what was the rate? 1.68 into 10 to the power minus 5, and the unit is mole per dm cube per second. So 1.68 into 10 to the power minus 5 mole. This is 5, not 3. Don't get me wrong. Mole per dm cube per second is equals to, well, this is the unit for rate, changing concentration per unit time. Here K. So now we're gonna involve the concentration of B. Okay. In this case, the concentration of the BRO3 whole minus bromate 5. The concentration of bromate 5 is 0.05. 0.05. 0.05 mole per dm cube. Okay. The concentration of H plus is 0.3 mole per dm cube, and the concentration of bromide is 0.25 mole per dm cube. Okay. So in here this is 0.3 mole per dm cube whole square, and this is 0.25 mole per dm cube. 0.25 mole per dm cube. Okay. Let's check it again. 0.3 mole per dm cube for H plus and 0.25 mole per dm cube for bromide. 0.3 mole per dm cube for H plus and 0.25 for yes, it's correct. And this is 0, not earth. Okay. So now let us simplify this thing up. 10 to the power minus 5 mole per dm cube and let us write this thing, that is it should be 1 if we have calculated if we have calculated we will get something like this 1.125. Okay. So if you have calculated this thing, then this should be, well, let me calculate. Yeah, this will come as 1.25 1.125 into 10 to the power minus 3. Okay. And if we multiply these units as well, then we will get mole per dm cube to the power 4. Okay. Then let us calculate k. let us make k the subject. Then we will get something like this: 1.68 into 10 to the power minus 5. This is 5, not 3. Okay, mole per dm cube per second. Okay, here it is 1.125 10 to the power minus 3 mole per dm cube to the power 4. So if we cancel this thing up, then it will come as 3. So here the value for k, so if you have calculate, you will get something like this: 0.0149, 0.0149, 0.0149, 0.0149 mole. Well, this becomes mole cube per dm to the power 9. So if we take this upward, then this should be per mole to the power minus 3, then dm 9 per second. So you know the simple arithmetic thing. So I hope that you know the simple arithmetic thing. So this should be mole to the power minus 3 dm to the power 9 per second. So this should be the answer to this question. So fellas, I hope that you have understood the question as well as the answer. So if not, please let me know which part of the solution you don't understand. So I'm happy to help you out. So if you have any confusion regarding this topic, please let me know in the comment section. I will have I'm happy to help you out. I'm gonna help you out, okay? So don't feel alone. I'm always there. Okay. So fellas, if you find this video tutorial helpful, I'm gonna provide the link to other episode. Okay. So I have solved the similar problems in a series. So I will put the link of the playlist at the end of this video tutorial. So I hope that you will find that helpful. So I'm gonna leave the link after this video tutorial. Okay. So until then, stay awesome. Best of luck for your exam, and as always, peace with chemistry.